Okay, guys, let's talk about our last transformation, and this is dilations. Dilations are non-rigid transformation. That means they are going to create similar shapes instead of congruent shapes. So a dilation can be an enlargement or a reduction. Sometimes instead of an enlargement, we call it a stretch. Instead of a reduction, we may call it a shrink. So these words are interchangeable. So with a dilation, we have a scale factor that we're going to look at, and we have a center of dilation. So our scale factor just tells us how many times bigger or how many times smaller our new shape is. The center of dilation is just a fixed point on the plane in which our pre-image is being dilated about. So if our pre-image is being enlarged, then all the points on the pre-image are going to be pushed away from that center point. If it is a shrink, all of the coordinates on the pre-image are going to be pulled toward that center of dilation. Most of the time, our center of dilation is the origin, 0, 0, but we will take a look to see when the center of dilation is an actual point on the pre-image. So we have two parts to dilations, the scale factor and the center point of dilation. Now the scale factor, we use the variable k to represent the scale factor. So if our scale factor is more than 1, then we are enlarging our pre-image. If our scale factor is between 0 and 1, such as 1/2, 1/3, 2/5, then we call it a reduction, and it is shrinking. Of course, if the scale factor is 1 and you're just multiplying everything by 1, you get the exact same size and shape of the pre-image. So let's take a look at how we can calculate the scale factor. So again, scale factor, we use the variable k, and jot this down in your notes. To find the scale factor, you take a value from the image, the new image, and compare it to its corresponding value of the pre-image. So it's the new value over the original value, new over original. So here we have two triangles that are similar. Triangle ABC is similar to triangle DEF. So to find the scale factor, it depends on which triangle is the pre-image. So let's say that DEF, this large triangle, is the pre-image, and we are shrinking it to create triangle ABC. To find the scale factor, K, we're going to take a look at corresponding sides, such as DE and AB, and we're going to compare the new value, we'll say 6, to its original value of 12 and simplify to 1/2. And we can see that our new image is smaller, and 1/2 indicates that we have shrunk our image. Now let's go the other way around. Let's say that ABC is the pre-image and DEF is our new image. To find your scale factor K, let's take a look at another pair of corresponding sides, BC and EF. So we take the new image length of 8 and compare it to the original length of 4 and simplify it to 2. And we know that when our scale factor K is more than 1, we have made an enlargement. And indeed, DEF is larger than ABC. So now let's talk about dilations where the center is at the origin. So here's a nice little subheading for your notes. When the dilation has a center at the origin, our rule is to simply multiply your coordinates of your pre-image by the scale factor to get your new image coordinates. Here is the notation. We have a capital D, we have a capital O for origin, and then K is going to be your scale factor. And then this will be your coordinate. And the rule is to multiply your pre-image coordinate by whatever the scale factor is. So I would jot this sentence in my notes. In this example, you can see that the blue triangle ABCD is our original shape, that is the pre-image, and you can see that A prime, B prime, C prime, D prime is our new image. And our center of dilation is the origin. So C is being pushed away from the origin, D is being pushed away from the origin, and so forth. Now let's take a look at some examples. We're going to write the rule. First, we are going to identify the pre-image coordinates. So we have A is -3, 1, B is -3, 2, and C is -1, 1. A prime is -6, 2. B prime is -6, 4, and C prime is -2, 2. So we know that our transformation is a dilation. Our center point is the origin, and so this is a capital O. And now we need to identify the scale factor. Now we could count and we could say that AB is 1 unit and A prime B prime is 2 units. So we could say that this is 2 compared to the 1. So K equals 2 compared to the 1, which is 2. But let's take a look and just compare our coordinates. And again, this only works when our center point is the origin. So the K value, we can simply take the new coordinate of -6 and compare it to the original -3. And when we simplify that, we get a scale factor of 2. So the yellow triangle is twice as big as the original blue triangle. Let's try another one. So A is 3, -3. B is 6, -3. C is 6, 3. A prime is 1, -1. B prime is 2, -1. And C prime is 2, 1. We have a dilation about the origin, and the scale factor is, I'm going to take my new image coordinate and compare it to the original. So it's 1/3 the size of the original. Now they give us the rule, and we are going to actually construct a dilation. First, let's identify our coordinates of our pre-image. So A is -4, 2. B is -6, -2, and C is -2, -2. So if we are shrinking this by 1/2, we simply multiply all of the pre-image coordinates by 1/2. That's really dividing by 2. So A prime is -2, 1, B prime is -3, -1, and C prime is -1, -1. Now let's plot these. -2, 1, that's A prime. B prime is -3, -1. And C prime is -1, -1, C prime. And you can see how this, our center is the origin, and A is being pulled toward 0, 0. B is being pulled toward 0, 0, and the same for C. So whatever your center is, the new image is being pulled toward if it is a reduction and pushed away if it was an enlargement. Okay, let's try another one. A is -3, -1. B is -3, -2. And C is -1, -2. We are dilating about the origin, so we can simply apply the scale factor of 2. We are enlarging, So all we have to do is multiply every coordinate by 2. A prime is -6, -2. B prime is -6, -4. And C prime is -2, -4. So everything's going to be pushed away from the origin. So we have -6, -2 for A prime. B prime is -6, -4. And C prime is -2, -4. And then we construct this triangle, and you can see our coordinates were being pushed away from our center of the origin. Okay, now let's take a look whenever the dilation is the center point of the dilation is actually on the pre-image. And you can see here that we have the blue triangle, ABCD is our pre-image. And then we have A prime, let's go ahead and write that in, B prime, C prime, D prime. So you can see that here, A and A prime are the same coordinate, and that therefore our center is at point A, and that's what's indicated here. Now, we can't just simply multiply our coordinates by the scale factor. We have to physically observe and count, and then count out how big or how long each pre-image is, and then see what our original length is, and we can define the scale factor. So you have to count the length of each side and multiply by the scale factor. So you can see that AB is 1, 2, 3 units, and A prime B prime is 1, 2, 3, 4, 5, 6. So it is 6 units. So therefore, the scale factor, we compare the new length to the original length. So we have a scale factor of 2, and everything's being pushed away from A. So that is our center point. So let's write the rule for here. We know we're doing a dilation. Now on here, we can see that B and B prime are the same point. So that is the point of dilation. We can see that we have AB right here. AB is 1, 2, 3. So we have A, B is 3. And then A prime, B prime is 1. So our scale factor is 1/3. Again, make sure you compare the new to the original. So we have A is going to be 6, -3. B is 6, -6. C is 3, -6. C prime is 5, -6. B prime is the same as B because that's our center point. So these two stay the same. And then A prime is 6, -5. And we can see that the yellow one was bigger, and then the green one, the new image, is smaller. And our scale factor indicates this. Okay, we have a dilation, and we can see our center point is A because A and A prime are the same. Now, let's compare. We have the green image, so AC. So to find the scale factor, I can compare AC to A prime, C prime. So AC is 2 units, and A prime, C prime is 1, 2, 3, 4. So our scale factor is 2. A is -6, -1. B is -6, 3. C is going to be 4, -1. A prime is the same as A because that's our center of dilation. B prime is -6, 7, and C prime is going to be -2, -1. So you cannot use your coordinates to multiply the scale factor by or or compare new over original when your center is not the origin. Okay, now let's do some constructions. So this time we have a dilation. Our center point is A, so A and A prime are going to be the same. So that is 1, -4 and 1, -4. So everything's going to be pulled toward A because we have a shrink, it's 1/2. So let's see, AB is 1, 2, 3, 4 units. So A prime, B prime is going to be 2 units. So this will be B prime, 2 units. And then AC is 1, 2, 3, 4, 5, 6 units. So half of 6 is 3. So A prime, C prime is going to be 3 units long. 1, 2, and 3. So they're being pulled toward point A because that's our center of dilation. So B was 1, 0, C 7, -4, C prime is 4, -4, and B prime is 1, -2. Okay, this time we are going to do an enlargement with a scale factor of 3. Our center point is point C, so everything's going to be pushed away from C. So let's see, C is 6, -3, and C prime will also be 6, -3. A is 3, -3. B is 3, -1. Okay, so let's just go ahead and see how long AC is. 1, 2, 3, and we want it 3 times that. So 3 times 3 is 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So A prime is being pushed way out here. So A prime is -3, -3. And then we have B. So let's measure AB. AB is 1, 2 units. So A prime, B prime is going to be 2 times 3, which is 6. So we're going to count up 6. 1, 2, 3, 4, 5, 6. And this is B prime, and that puts us at -3, 3. And now we can connect our vertices to create our enlarged right triangle. Okay, now on these ones, guys, we can simply multiply the scale factor by each coordinate because our center is the origin. So we're just going to multiply everything by the scale factor. So 12 times 1/3 is 4, and then -6 times 1/3 is -2. So that's our new point. Now we're going to multiply by 3/2, and we have 2 goes into 6, 3, so that's going -9. And then 2 goes into 8, 4. 4 times 3 is 12. And of course, you can use calculators, guys. You can use a calculator. And now we have an enlargement. So we're going to multiply our pre-image coordinate by 4, and we get -4, -16. Okay, now we are going to write the rule, and our center is going to be the origin. So we're going to take one new, so I can take this new coordinate and compare to the original. So we're going to have -8 compared to -12, and then that simplifies by a factor of -4, and we get 2/3. So our scale factor is 2/3. Next, we can compare again, just this x coordinate 12 and compare it to its original coordinate 8 and simplify it by a factor of 4 and get 3/2. And then our last one, our scale factor, we can take -6 and compare it to its original -15. They both have a factor of -3. So we have a scale factor of 2/5. And I hope this helps.